Okay, folks, we got our homework prep, Unit 7, Day 2. We're going to be talking about point-slope form today. Take a moment to write down your learning objective, these two things. Graph a line given a point and a slope, and then also write the equation of a line in point-slope form. If you guys would also write down what point-slope form is for me. This is point-slope form. It's another way to write an equation of a line. Take a look at our first example. You're given a point 3, 1 and a slope of 2. That's a point and a slope. I want to practice graphing this line. Okay, so 3, 1 would be here. Go ahead and make that point. And then we have a slope of 2. Remember that a slope is a ratio. So what we have there is 2 over 1. So what that's telling us to do is to go up 2, right 1. So from my point of 3, 1, I'm going to do that pattern. Up 2, right 1. Up 2, right 1. I can also do the pattern backwards to go down 2, left 1, and so forth. And I can generate some points on that line. When I draw the line connecting those dots, what I have is the line that goes to the point 3, 1 that has a slope of 2. Okay. Now you'll notice in the next column, we now see the whole line. We could write down the equation of this line in slope-intercept form. We can see that it comes down here and it crosses the y-axis at -5. That means that our b is going to be -5. And we know our slope, it told us it was 2, so our m is 2, or 2 over 1. So I'm going to go ahead and write the equation of the line as y equals 2x minus 5. Now we could also write this a different way. We could write this in point-slope form. And both the y equals mx plus b and the point-slope form are both correct. However, one may be advantageous over the other. The way that you write point-slope form is you start with the point and the slope that were given to you. They told us that our slope was 2, and they give us the ordered pair is 3, 1. Well, this ordered pair 3, 1, we want to think of that 3 as our x1 and that 1 as our y1. And we're going to plug those values, along with the m, into the equation. What we get is the equation of the line in point-slope form. So what we got here. We'll have y minus, there's our 1, equals 2 times x minus, and then there's our 3. That is the equation of that line in point-slope form. They're both correct. The one over here on the left and the one over here on the right are both correct representations. What I'm going to show you here in a moment, I want you guys to copy down with me, is to show you that they are exactly the same. For instance, if I wanted to solve this equation here on the right for y, I could do a quick little distributive property, and I get 2x minus 6. Then I can add away the 1 to get the y by itself. And what I end up with is y equals 2x minus 5. These guys are the same line. Okay, let's take a look at number 2. Let's do an example. Here I have -2, 3 in the slope, 3 halves. Copy that down for me. And let's plot this point. -2, 3 is here. And from that point, I'm going to do a slope of 3 over 2. So that means I'm going to go up 3, right 2. Okay, so let's do that. That also means I could go down 3, left 2, and begin generating some other points. That is the line that goes through the point -2, 3 and has a slope of 3 halves. Okay. Well, we can write what this equation is by looking at the graph. Okay, we know that it has a slope of 3 halves. That was given to us. We can also look at the graph and see that its starting point, or where it crosses the y-axis, is where b equals 6. Right? Remember that we put a dot there. Now let's just plug those values into the equation. Y equals 3 halves x plus 6. Okay. That is the slope of that line in slope-intercept form. Let's do the same thing with point-slope form. Well, they gave us that the slope is 3 halves, so that's going to be the same. And they gave us a point on the line, -2, 3. That -2 is going to be our x1. That 3 is going to be our y1. Okay, let's plug those values in and see what we get. We'll get y minus 3 equals 3 halves times, now here's what's tricky. It says x minus x1. So we have x minus, but then x1 is a negative 2. So you'll recall that when we're subtracting that negative, what it's basically going to end up being is a positive. So we're going to have y minus 3 equals 3 halves x plus 2. Point slope form. To show you once again, and please copy this down with me, we could convert this into slope-intercept form. Do a little distributive property. We get 3 halves x plus 3 halves times 2. We'll just put that 2 over 1. We end up getting 3 over 1, or just a positive 3. Now add that 3 away, and you can see that we verify that those are, in fact, the same lines. Okay, let's do the last one together. We have the point 4, negative 3. We have a slope of 0. Write that down for me. 4, negative 3 is here. Now, slope of 0. Remember, that's different than no slope. Slope of 0 does actually have a value. Okay, so it's not positive, it's not negative. It's in the middle of those two. What we get is a horizontal line. Okay? You'll notice that it crossed the y-axis at negative 3. That means that our b is negative 3. They gave us that the slope is 0. Let's plug those values in. Y equals 0x minus 3. Or if you wanted to, you could just write that as y equals negative 3. Both of those guys are correct. Okay? Let's write this in point slope form. They've given us the slope as 0. They have an order pair 4, negative 3. Here's our x1. Here's our y1. Let's plug those guys in. So let's see, y minus a negative 3. So when we subtract that negative, that's going to mean it's going to be a positive. So y plus 3 times 0 times, x minus 4. Point slope form. To illustrate once again that these guys are the same, you can do a little distributive property. When you distribute that 0, you're basically just going to get 0 plus 0, or just 0. Subtract away the 3. And looky there, same thing. Okay? All right. Take a moment to flip over to the back side, and you're going to take a look at a couple of different examples. I want you guys to try these on your own. Okay? So go ahead and do the whole thing. Plot the point and graph it. Write it in slope-intercept form, and then write it in point-slope form. Okay, here we go. Remember, think of that as negative 3 over 4. So down 1, right 4. That negative in the middle only goes to one of the numbers. So you can go down 3, right 4, or you could go up 3, left 4. Either way, you're going to get this line here. Okay. That is y equals negative 3/4 x plus 3. We could also write this as y minus 0 equals negative 3/4 x minus 4. All right, second example. Go for it. All right, 2, negative 7 somewhere down here. And you'll have a slope of negative 1 over 1. So down 1, right 1. So we're going to run out of room down here on the bottom, but we could work that pattern backwards. We could go up 1, left 1. We'll end up with this pattern here. Okay. Well, that gives us the line of y equals negative 1x minus 5. Okay. Point slope form, you're subtracting the y value, so that means you're subtracting a negative 7, means you're going to add it. The slope is negative 1 times x minus 2. Okay. Last example. Go for it. Okay, so from here I'm going to go up to right 5, or I could do that pattern backwards and go down to left 5. Okay, you can see it crosses the y-axis at 4. So the equation of that line is y equals 2/5 x plus 4. We could use the 5 and the 6 over here to have y minus 6 equals 2/5 times times x minus 5. Okay. Come into class on the next time with this completed and ready to go. And I look forward to seeing you.